In this video, I'm going to go over another problem, problem 3 from the Math 256 Midterm 2 from March 2015. So question 3 asks you to complete solving an equation where you're given the transform of the solution and they're asking for y of t, the solution. So let's write this down. So we have y of s is equal to 20 divided by s multiplied by s squared plus 4s plus 20. So there are a couple approaches. One approach that several students took, which I think is more difficult, and that is to recognize that this transformed solution is a product of two transforms, each of which you can calculate separately, and then you use that fact to find y of t by taking the convolution of the inverses of each of those. That integral turns out to be a little bit messy, and so I'm going to do it a different way. I'm going to say let's split this up into two separate pieces by using partial fraction decomposition. So I'm going to take one factor here, and that becomes an a over s once I split them up. And this factor here, we have to check to make sure that this has roots or does not have real roots. And the way to do that is to quickly check the discriminant, which is b squared, 16, minus 4 times 20 is minus 80. That's a big negative number, so this has complex roots only. So that means we use the form bs plus c divided by the non-factorable denominator, s squared plus 4s plus 20. Okay, so the partial fraction decomposition approach tells me that these two polynomials should be equal. And as you can see here, I have an s squared multiplied by an a plus b. There's the a and there's the b, and that has to be 0. So a must be the negative of b. And then on the s terms, we have a 4 times a and a c, so we have 4a plus c equal 0 because there's no s term on this side, and that means that c is equal to minus 4a. And finally, the constant term 20 times a, and there's no constant here, must be equal to 20, so that means that a must be 1. And going back up to here, that tells us that b has to be minus 1. And finally, that c has to be equal to minus 4. So we can rewrite y of s as 1 over s plus, well, I'm actually going to write that as a minus out in front because both the b and the c have a minus sign in them. So now I can write it in the numerator as s plus 4 all divided by s squared plus 4s plus 20. This is in the form we can quickly take an inverse transform and we'll get the constant 1 in the inverse transform. But for now, let's manipulate the other expression first. Because this is not factorable, we have to complete the square. And so we still have the s plus 4 in the numerator, but in the denominator, I'm going to take the coefficient on the s, divide by 2, and I get 2, square it, and I get 4. So I need to have s squared plus 4s plus 4, and then whatever's left over, 16. And so this means that I should write y of s as 1 over s minus s plus 4, all divided by s plus 2 all squared, my completed square, plus 4 squared. So you can see that I have an s plus 2 down here in the squared, which means I really want an s plus 2 up here. That means I'm going to have to split this into two pieces. So I'll split it into negative s plus 2 over s plus 2 squared plus 4 squared. But then I have to account for the extra minus 2 that I don't have here, so that would be a minus 2 divided by the same denominator. Finally, this is now also in the right form, so the first two pieces are in the right form. What we want here is the correct form for the transform of a sine function, and that's almost correct, except we have a 2 here instead of a 4 in the numerator. So when we rewrite this, we're going to multiply and divide by 2 so that we get that 4 in the numerator. And so we have all of this exactly the same. And finally we get minus 4 and I need a half in front so that the overall coefficient here is, as it was before, a 2. And now when I take the inverse transform, I can just do that term by term easily now, because I've cooked them up all into the right form. And so I get the inverse transform of 1 over s, that's just 1. The inverse transform of s plus 2 over s plus 2 squared plus 4 squared is, well, I have a minus sign in front, and then an e to the minus 2t from that s plus 2, and then the form of the rest of it is the transform of a cosine for t. And then minus 1/2 e to the minus 2t sine of 4t. And that is the solution, given that the transform of the solution was y of s as above. Okay, so that was part A. In here, let's see, you should be getting 1 point for each of the 2 forms of this partial fraction decomposition step. So there's 1 point for getting this form correct and another point for getting this form correct. And then another point, actually 2 points, for the 3 coefficients. If you only got one of these 3 coefficients, you wouldn't get any points. If you got 2 of them, you'd get 1. If you got all 3, you should get 2. And then further points for completing the square, for separating out and putting it into the correct format for the cosine inverse, and getting into the right format for a sine inverse. So that's 1, 2, 3, 4, 5, 6, 7, and finally 1 more point for taking the inverse transform of all of the pieces correctly. So that's a total of 1, 2, 3, 4, 5, 6, 7, 8 on that part. And then there was another 2 points for giving a differential equation and initial values that would have a transform solution y of s. So this one, there's actually at least 3 solutions that I know of, but there's possibly others. Oops. So the first one is to assume that the s came from the transform of the right-hand side, and the s squared plus 4s plus 20 came from the transform of the left-hand side. So that means that you initially had a y double prime plus 4y prime plus 20 times y equal to 20. When you take the transform of 20, you get 20 over s and then divide through by the transform of all this business. In that case, you would want to have y of 0 equals 0 and y prime of 0 equals 0 as well. So that's one possibility, and in this case you would get 1 point for the correct or a correct equation and another point for the correct initial conditions. Another example that works would be y prime equal, and now we're making the assumption that the s came from the equation and the 20 over s squared plus 4s plus 20 came from the right-hand side. And so now in that case we'd have an e to the minus 20, right, first, times e to the minus 2t times the sine of 4t, and so that 20 would actually be partly a 4 from the transform and a 5 from the original function. So we actually need a 5 in there. And when you take the transform of this, you would get exactly the pieces that you need to get this y of s. And so in this case, again, y of 0 is equal to 0. And there's a third one using y triple prime, and I'll let you think about that one and see if you can figure it out.